In the previous lessons, we learned about chemical reaction, and that in a chemical reaction, reactant, they react with each other to form a product. Now in this lesson, we are going to learn about a chemical reaction that is reversible. Think of the term reversible as in going backward, so keep that in mind. Reversible is going backward. So if a chemical reaction is reversible, it can go forward and backward. Well, in a reversible reaction, the reactant are producing new product, just like a normal chemical reaction. But at the same time, that's the key thing, at the same time, some of the product that are already made, some of the product will react with each other. So the product are now reacting with another product to become their original reactant. To illustrate this example, we have reactant over here. So these are reactants. And these over here are product. So if you notice, the arrow is a two-direction arrow, one going forward and one going backward. So this product here interact with each other to make the reactant again. And at the same time, this reactant will react to make the product again. And this process is happening at the same time. We consider this as the forward reaction, as reactant making product. And then this process where the products are making the reactant, that's considered the reverse process. So the forward and the reverse process are happening at the same time in this closed system. When we use the term system, we are talking about the chemical reaction. So this right here itself is a system that we are going to focus on, okay? And what's so special about the chemical reaction that is reversible? In a system of a reversible reaction, the reaction will naturally fix itself to be at equilibrium. And what is equilibrium? Well, equilibrium, look at one thing. That is the rate of forward and the rate of reverse reaction. That means going to make the product, and this is going to become the reactant again, are equal to each other. So the rates are equivalent. They are equal to each other in an equilibrium chemical reaction. Because of that, we can now control how to make more product or make more reactant. Well, there's one guiding principle called the Le Chatlier principle. Le Chatlier principle states that whenever stress is placed on a system, which is a chemical reaction here, okay? So system is basically another word for chemical reaction in this term. The system will shift in a certain direction to either make more product or reactant. So again, this is the forward reaction, and this is the reverse reaction. Keep that in mind. When we are making reactant, we're going backward. When we're making product, we're going forward. And they will continue to shift in that direction until the forward and the reverse rate, this is talking about the rates, are equal again, okay? And we consider this at equilibrium. So that's very important. This allows understand the term equilibrium and in terms the rates of forward and rates of reverse. So this is not like the same problem we did before with a lot of math problems, but it's a lot of very conceptual understanding. Equilibrium is about the rates of forward equal to the rate of reverse. In order to understand the Le Chatlier principle, let's look at an example. When more reactant or product is added to an equilibrium system, the reaction will shift in the direction that allows the reaction to use up all the added substance until the rates of forward and reverse are equal again. So again, let's look at this example. If a student add more CO2, so CO2 is right here, okay, and that is your reactant, okay. If more CO2 is added to the above, so right here we are adding stress, okay, stress being added to the reactant side. The reaction will shift toward what? Well, if we add more of CO2, if the stress is on this side, we have to go forward. That way the stress is being reduced. And how does that work? Well, what's happening here is that we are going to shift the direction of making more product. Okay? Remember, the forward and reverse are happening at the same time. But when you add CO2, now it's going to go toward the product side more, in order to balance that stress, okay? And in the process, it's going to use up all that CO2 that's being added to make more product. And this will continue to happen until all the excess CO2 is being used up. So we talk about the excess, okay? It's being all consumed and used up to make more product, so that the rate of forward and the rate of reverse is at equilibrium again, which is the same values. So the rate of forward and the rate of reverse must be the same. Now let's look at another example. If a student add more of this compound here, which is the product side, okay? So the product side, if we're adding stress to this side, well, what's going to happen? The reaction, of course, is going to shift toward this way to reduce that stress. So what's happening here is that it's going to shift toward the reactant side, making more reactant. And at the same time, and in the process, it's going to use up the HCO3. Well, this is our excess. Remember, we added in, right? Because of added. Until the rate of forward and the rate of reverse is the same again. And equilibrium is re-established again. And by understanding the concept of chatlier principle, we can control a system to make more of the product or to make more of the reactant, whichever we like.